welcome to this video. So in the previous video on network address translation, I talked about static NAT. We said in static NAT there is a one-on-one mapping. So you will have to buy public IP addresses from your internet service provider. And if you're able to buy free public IP addresses, there are only 3 people in your network, 3 hosts in your network that can access the internet. Those IP addresses are going to be mapped, statically mapped, meaning that host owns the public IP address. No one else can use it. Whether the host is being used or not, no one else can use it. It's kind of not so effective, although it's really good because it provides bidirectional NAT. So the outside can access the inside proactively, and the inside can also access the outside proactively. But as I've mentioned, it's a one-on-one mapping. So in this video, I'm going to be discussing dynamic NAT. Which differences does it bring? How better is it from static NAT? And how exactly can we have it configured? So in dynamic network address translation, a private IP address is mapped to a public IP address from a NAT address pool. That right there is the key statement. We are mapping to a NAT address pool. In other words, instead of statically configuring that this private IP is mapped to that public IP, and this private is mapped to that public, and this private is mapped to that public, we don't do that anymore. We are going to log into this router and set up an address pool and say, hey, you know what? This is our public IP, this is our public IP, and this is also our public IP. And then when no one is accessing the internet, all those public IPs are not in use, as you can see in this illustration. When a certain user accesses the internet, their private IP is going to be converted to the first available public IP, and then it is going to be labeled as in use. Now, the beauty of this is that when this user stops accessing the internet, the IP address is still available for another person to use. So there is going to be change in usage of these IP addresses because the system, the device is going to intelligently allocate to any free public IP address in the system. So as I mentioned, in static NAT, there is strict mapping of addresses in a one-to-one mode. As a result, even if an internal host is offline for a long time or does not send data, the public address is still occupied by the host. Now, in dynamic NAT, we prevent such address wastage. When an internal host accesses an external network, an available IP address in a NAT address pool is temporarily, that's key, assigned to the host and marked as in use. When the host no longer accesses the external network, the assigned IP address is reclaimed and marked as not in use. That is kind of the benefits of DHCP. We looked at DHCP in another recording. You might want to check it out if you don't know how it works. So let us look at an example implementation of NAT. So in this example, host 1 attempts to access the internet, and when its packet reaches there, the device checks the address pool and realizes that number 1 is already in use. So it's going to assign host 1 the second address right there. That's what it translates it into and reaches the destination. And of course, the result when it finishes assigning, it will add the entry into the NAT mapping table. So the NAT mapping table is going to be a dynamic table that is going to be generated as assignments are done. And unlike the static NATing, where it's a static table it's there and fixed, in this case, it's going to be generated as we assign. When someone attempts to access the internet, this guy attempts to access the internet, this address is assigned to him and entered in the address table. When another guy attempts to access the internet, the next available address is assigned to them, and so on and so forth. That means this guy maybe used the internet for 30 minutes and logged out. The address goes back to free. It's available. Another guy attempts to access. It's now the free address. It gets accessed. Whereas it is still only 3 users that can access the internet at any given instant. This time, more than 3 users can access the internet using 3 public addresses. I really hope this makes sense. It is only The number of addresses available is the maximum concurrent number of users we can have accessing the internet. However, this number is not static. It is not John and Alice and Alex that can access the internet because we have statically mapped their private IPs to the available public IPs. Alice and Alex, excuse me. It can be John and Alex and Joram and Umar and several people. As long as an IP is free in the pool, it can be assigned to the next person who is accessing the internet. So whereas dynamic IP we have seen solves the first problem of static IP of one-to-one mapping by introducing a dynamic pool, a dynamic NAT table that is based on the pool that is used as required or as requirement arises. It still faces a problem that you have to purchase the number of public IPs that is equal to the number of internet users you have. That does not work so well all the time. And also, the other problem with this network address translation implementation is that it's not bidirectional. This guy cannot proactively access this guy because he doesn't even know which IP has been assigned to that guy. So it cannot do bidirectional. It only does when it's internal network accessing the external network. Internal network accessing the external network. It does not work the other way round. So let us look at an example configuration. This is the same example that we look at here. In this case, we are looking at another device sending a reply. This device sending a reply back. You can see from that IP to that IP, gets here, checks the mapping table. Of course, this mapping table I've mentioned is temporary. So it checks the temporary table, gets a match, and then it will send the reply to the host that originally asked. Again, when this host stops using the internet, this entry is going to disappear from the NATing table, from the NAT mapping table, and in the address pool, that particular address will be marked as available or not in use. Now, of course, you would expect a small difference in the configuration of dynamic NAT. We are not setting up a static NATing mapping table because the router will generate that intelligently. But we need to set up an address group, a range of public IP addresses we have that we want to be using on our router. So we use the command NAT address group and then the start address and also the end address. After that, we need to identify which addresses are allowed to be translated. Now, sometimes we have 1.1, maybe these are the only two guys we accept to speak to the internet. And so we are going to use an ACL to identify traffic from these guys, and that is the traffic for which the IP addresses will be translated. So we are going to use an ACL and specify the number, ACL number, and then rule permit source, specify the source address and the source wildcard of the addresses in the network that we want to be translated. And those are the ones we permit. Others will be denied. Permit in this case means those addresses will be translated. Deny means those addresses will not be translated. Now we'll go to the outbound. We'll configure outbound NAT with the address pool on the interface view by going to the interface at which you want to terminate NAT and say NAT outbound, and we bind it to an ACL. We invoke the ACL. The ACL will be identifying the networks that we want to translate, and we specify the address group that we want to use for NATing, the address group or the NAT pool or the public IP pool, and we specify the command no path, means that we don't do port address translation. An example configuration is right here. We are setting up NAT address group 1, starting from 122.1.2.1 up to 122.1.2.3. There are 3 IP addresses. Then we define a basic ACL and set up a rule 5 permitting all traffic from the .1.0 network, as you can see. Of course, all that traffic, the whole network based on that wildcard. So we shall get out of the ACL and go to the interface and say NAT outbound. Then we invoke ACL 2000. We shall be translating addresses that match SCL 2000 only and bind translating to the addresses that we define in address group 1. We are not doing port address translation. I'll be talking about port address translation when I'm discussing the next implementation of network address port translation or network address translation that we call PAT, port address translation or network address and port translation together with HCIA. So this is what dynamic NAT is. It is a bit of an improvement to static NAT because we are not statically mapping IP addresses, but it still needs us to purchase the number of internet users we have. The number of public addresses needs to equal to the number of internet users we have. Otherwise, we can only have the number of internet users accessing the internet equal to the number of public addresses we have. Well, the internet users can change, but the concurrent ones accessing will only equal to the number. These are 3 public IP addresses, so only 3 people can access at any time, concurrently, only 3 people. If we need a 4th person to access, they will find all the IP addresses are used up, so they can't access the internet until one of these goes offline. That is the challenge with NAT, and that is exactly one that drives us to PAT or to port address translation, also called network address and port translation, which we'll cover in the next video. I hope this has been informative for you, and thank you for viewing.